Good afternoon to all of you. This in this aromatic compounds, now we are going to study the characteristic of aromatic compounds. One of the important characteristic of the aromatic compound is the unsaturation. The aromatic compounds are unsaturated compounds having the double bonds in the conjugations. Though if only carbon atom present in the ring, they are called as homocyclic or the carbocyclic compounds. Here the example is the benzene ring. In the benzene ring there is unsaturation, that is sp2 hybridized carbon atoms. All the 6 carbon atoms are sp2 hybridized. Next, aromatic characters. Main important aromatic characters means aromatic nature show in the chemical reactions is the substitution reactions, because it is the substitution reaction, it is shown by, especially shown by the aromatic compounds. When we performing the any reactions along with the aromatic compounds, at that time there are the two options for these reactions. One will be the nucleophilic substitution reactions, another will be the electrophilic substitution reactions. With the substitution reaction is the options available for the reactions. So aromatic compounds always show the substitution reactions, whereas the saturated compounds always show the addition reactions. Benzene exhibits the aromatic nature, and it is a highly unsaturated compounds which never show the addition reactions but always show the substitution reactions. There are the number of substitution reactions are available for the aromatic compounds. Okay, Friedel-Crafts reactions is there also. Friedel-Crafts acylation reaction is there. Okay, addition substitution reactions. Many substitution reactions are there which are added on the benzene rings. Okay, so these are shown by the aromatic compound substitution reactions. Next point, important point, is the stability of the rings during the oxidation reactions. It is a property, aromaticity is the property of the cyclic compounds, and cyclic aromatic compounds are highly unsaturated compounds and undergo the substitution reactions which does not show the addition reactions. It is proved by the result of the some reactions. Because why it is not showing the addition reactions, reason is that if any compound showing the addition reactions, then it may chances that, or it will lose the aromaticity. Means the sp2 hybridized carbon atoms it loses. That's why it show only substitution reaction. After substitution, it regain its aromaticity and the stability. Some reagents and the reactions are here. Oxidizing agents are there. chem-II is the rapid oxidizing reactions. When react with the benzenes, no reactions is occurred. Means it is a stability of the benzene ring cannot be affected by the chem-IV. If you add the HBr, rapid addition takes place, but no effect on the benzene rings. So the no oxidation of the benzene ring indicate that the benzene ring is the aromatic and have the marked stability on the rings. Because the aromaticity it is itself is the highly stability of the compounds. Every compounds, if it is a non-aromatic, it try to get the aromaticity, because if it converted into the aromatic compounds, it will get the stability. So every reaction goes toward the stability, and if any compound is already stable, they cannot lose their stability. Means they cannot show the reactions in which the chances of the losing the stability. That's why it cannot be reacted with the KMNO4, it cannot be reacted with the HBr, because it may have the chances to lose the stability. So chemical reactions also the favors to stability, also favors the aromaticity. Summary of the characteristic of the aromatic compounds. They are the highly unsaturated compounds as indicated by the lesser number of the hydrogen atom in their molecule formula. They are cyclic compounds having the 5, 6 or 7 membered carbon containing rings. Aromatic compounds give the substitution reactions instead of the expected addition reactions. They have the conjugation of the double bonds. They show the resistance toward the oxidations. They have the lower value of heat of hydrogenations, and the combustion than the expected from the calculated types of structure. Next point is the criteria of aromaticity. The planarity of the rings and the presence of the conjugated double bonds in the rings are the primary requirements of the compound to be the aromatics. Because aromatic compounds are planar in nature, so planarity is important, because for the conjugations, if there is a non-planar rings, then conjugation cannot be possible. So for the conjugations, planarity important, and planarity is the basic concept for the aromaticity. Second is the Hakka rule. What it says? Hakka rules used for the aromaticity, which state that if any unsaturated compounds containing the 4n plus 2 pi electron system, which are conjugated and involved in the resonance, will have the special stability which is called as the aromaticity, where n in the formula is indicated that 0, 1, 2, 3 is called as Hakka numbers. If n is equal to 0, then the 4n plus 2 is equal to 2. If n is equal to 1, then the 4n plus 2 is equal to 6. If n is equal to 2, then the 4n plus 2 is equal to 10. If n is equal to 3, then the 4n plus 2 is equal to 14. Because if we put the value of n is equal to 1, 2, 3 in the formula, then the conversion will be the 2, 6, 10 and 14. So in case of the benzene ring, there are the 6 pi electrons. In case of the naphthalene, there are the 10 electrons. In case of the phenanthrene, there are 14 pi electrons. So it is aromatic in nature. For the molecule to be aromatic, the number of pi electron on the ring should be either 2, 6, 10, 14, etc. So it must be the stability, and it must be the follow the Hakka rules of 4n plus 2 pi electrons. Next is the categories of the aromatic compounds. On the basis of the structure, the aromatic compounds are of the three categories. Benzenoid compounds, these are the compounds having the one or more benzene or benzene-like rings. Benzenoid compounds, benzene-like ring containing compounds. This is a category of the benzene aromatic compounds. Benzene means benzene ring, naphthalene ring, phenanthrene ring, anthracene ring having the benzene-like structure. So it is called as benzenoid compounds.